Okay, I'm just going to go over the homework that you had last week because it did seem to cause a few problems. Maybe some of you are feeling better about this subject now, but I just wanted to give you the opportunity to go over it again with some feedback. Okay, so a number of you got this first question wrong. pH of 0.02 moles per dm cubed of a diprotic acid, and that's because you forgot to multiply that concentration by 2 if it's diprotic, like H2SO4. However many moles of the diprotic acid you've got, you're going to have 2 moles of H+. But once you've done that and you take the pH, then it's obvious. Question 2, again, a lot of you got this wrong. You had to pick one or more of the options that you were given, and you were, kind of 1, 2, and 3, or 1 and 3, etc. So the answer was B, 1 and 3. So solutions with a pH of 1 will include, well, it's going to be something 0.1 in that sense, because if you take 10 to the 0.1, then you end up with 1. If you take the log of 0.1, you end up with 1. So 0.1 moles of hydrochloric acid will give you a pH of 1, but because sulfuric acid is diprotic, then you've got 0.1 moles of H+, and that's going to give you a pH of 1. The other two options, ethanoic acid, a weak acid, so that doesn't apply in terms of pH. And nitric acid, the concentration is too high and would give you a pH of 2. Okay, question 3. So you're told that the calculation involves 2 strong acids and 1 weak acid. You're given information about temperature and you're given information about concentration and volume. So to calculate the pH of a new solution formed when you take 25 cubic centimetres of a certain concentration of HCl and you add 100 cubic centimetres of distilled water. Okay, so you need to initially calculate the number of moles of HCl that you've got, and then you need to work out the new concentration in the new volume, i.e. 125 cubic centimetres. Once you've got that, you just take the minus log of that value. That's your concentration of H+. I think everyone got this right, writing the expression for Ka. The only thing I think maybe some of you did was write H+ squared, which you shouldn't do. If you're asked for an expression for Ka of a particular acid, whether they give you a general term like HX or whether they give you a specific acid, you don't write H+ squared, you write it out fully. So you've got the H+, you've got the conjugate base, and then you've got the undissociated acid on the bottom. Okay, and then you're asked to calculate a value for the acid dissociation constant, and you're given pH. Okay, so this is just really all those equations I gave you on that sheet. It's working out or knowing which one you're going to use and which one you're going to which one you've got the information to use effectively. So you're given pH here, so you can work out the concentration of H+ by taking 10 to the power of minus the pH, which in this case is 2.79. That gives you the concentration of H+. So then we can work out Ka using the H+ squared expression. So square root H+ is going to be H+, you're going to square that value, 1.62 times 10 to the minus 3, which you calculated, and then you're going to divide by the concentration of your undissociated acid. Okay, I asked you for 3 significant figures, so that's what you need to give your answer to. And part C, again, we're given some information, nitric acid, but this time we're adding sodium hydroxide to it, and then you're told here that the ionic product water is 1 times 10 to the minus 14. Okay, so you know that you're going to have to use that expression, and this is the expression for the ionic product of water. And if we rearrange for H+, which is going to enable us to calculate pH, we can see that we need to work out concentration of OH minus. So that you have to go through a series of steps. Now this is 6 marks, so you know that it's not going to be a straightforward, one calculation. There's a little bit to it, but we need to do that. So we work out our number of moles of OH minus sodium hydroxide, which we take from this information. We've got a volume, we've got a concentration. So our concentration times volume gives us the moles. We do exactly the same for H+, and we work out the moles. Now we have to work out what our excess of OH minus is. So, we've got these 2 moles, so the larger number, take away the smaller number, tells us the excess of moles of OH minus, and now we need to convert that to concentration of OH minus. But this time, don't forget, you have to use the total volume. You need to add together the 25 and the 38.2, which gives us 63.2 cubic centimetres, divided by 1,000 to give us cubic decimeters, and that tells us our concentration of OH minus. So we can now put that into our rearranged KW expression. So we've got the value of the constant, the water dissociation or ionic product of water, divided by the concentration you've just worked out, and then we take minus log of that value, and that gives us the pH. So you've got that extra step in there, working out the moles of both, finding which one is in excess, making sure that we've got the right values to put into our rearranged equation. So whenever you've got a strong alkali like Na, and there'll always be strong alkalis in your questions, you're going to have to go through this process. And question 4, okay, so tells you here to give all values of pH 2 decimal places, so that's important. Straightforward here, expression for pH, expression for Kw. To calculate the pH of water, now you're given a value for Kw here, and the reason you're given that value, and it's not the same as the standard value that you're used to, is because this is at 50 degrees C, not 25 degrees C, so it's bigger. But, you just put that value in. So in this particular case, we can say that, so this is the expression for Kw, but when we're actually using it in this context, we can now square it, because we're saying that these 2 values are going to be equal, because we're just looking for pH of water. So squared, we know the value for Kw, so we'll rearrange it for H+. Concentration of H+ will be the square root of Kw. In this case, our Kw is 5.48 times 10 to the minus 14, which gives us this value. That's the moles per dm cubed. Take the minus log of that, and that gives you pH. Suggest why the pure water is not acidic, because that's pretty neutral, 6.63, is because your concentrations of both the ions are equal, because to make it acidic, we need more H+ than OH minus, don't we? Okay, and then you're told to calculate the pH of a particular concentration of aqueous sodium hydroxide at 50 degrees C. Now you're given this information here, which is confusing because you're told up here that the value of Kw is that, but that's at 50 degrees C. Don't forget this is actually at room temperature. So I have actually allowed, if you use this value and you got the answer right for that, then I have actually allowed those marks. but technically you should have been using this value because it's at 50 degrees C. It tells you that in the question. So yeah, so that's our KW, that's our concentration, and because it's total dissociation, it's very straightforward. That's now your concentration of H+, and there's your pH. And then the last part of the question, again, is another 6 marks, so you know it's going to be a little bit drawn out. pH of solution when we add sulfuric acid and potassium hydroxide, which again is a strong base, a strong alkali, at 25 degrees C. Assume that the sulfuric acid is fully dissociated, so we can assume that those 2 hydrogen ions will be fully dissociated. So first things first, it's very similar to the calculation we did in the previous question. Number of moles of acid, which works out at that, but of course number of moles of H+ in this instance will be times 2. We've got twice as many moles of H+ as we have moles of acid. Moles of NaOH, which you're taking from the concentration and the volume. Find the excess of H+ in this case, because that's the bigger number. 1.5 times 10 to the minus 3. So there we are. Divide that by the total volume, 30 plus 55. Gives us a concentration, and then we just take minus log of that value, and that gives us our pH. So that really, just those few questions in your homework. If you are having problems with any of them, hopefully the feedback has helped you, and if not, then please make sure you come and see me. Thank you.